BL branch with link instructions. As I told, so it before branching to the specified level, the PC is stored in the link registers. So it is address of the next instruction after the BL. The BL stores, the LR stores the address of the next instruction after the branching. So I have shown you with memory. So this is some part of the main program. Some other instructions are there in the main program, and end I am not using. Only I am using some part of the main program where the subroutine instruction is there. Okay. So this is the BL. In the case of the C language, we use the call name of the subroutine. So here we are using, in place of the call, we are using branch. It is a link register. Okay, to the name of the subroutine. So you can give the name of the subroutine, anything you can give. Even you can give your name also. So then here also your name. Okay. So whenever it calls the subroutine, the service processor has to transfer the execution from this memory block where the main program is stored to the memory block where the subroutines are stored. Okay, so how it does? By changing PC values from PC is equal to Y to, so PC is equal to A. Now the program counter is a path pointer to the execution operation. So that is what PC is pointing to the memory location A. So it come to the processor come to this memory location. Whatever instruction is there in this memory location, it starts executing. So at the end of this, LR is the previous content of the program counter. It has been loaded to the program counter. Now the program counter is pointing to the Y. That's what the execution is returned back to the main program where it has been halt. Okay. So the difference between the subroutines are called whenever you are specifying this instruction, branch link to subroutine. Okay, at this juncture only subroutines are called. In place of, for example, if you are written BL subroutine here, at this point the subroutines are called. Wherever, in the case of the interrupt can occur at any time while executing this, or while executing this, or while executing this. There is no control on the interrupt generated by the external devices. The difference is it is the same only. The previous content of the PC is loaded to the LR, and the PC is loaded with the ISR, starting address of the ISR. So along with that, it set IF is equal to 1, because second device generate the interrupt. Before generating interrupt to the processor main program, it check the IF content. Okay, IF is equal to 1. The second processor understand that already the processor is giving service to the first slow device. I should not generate the interrupt. So whereas here in the case of the subroutine, only move PC to LR, and in this case up to the end of the ISR, we have, along with the move PC LR, we have IF is equal to 0 also, because doctor take the first patient before treating him. Generally, small hospital or go to the big hospitals, he is sitting in the room. Before attending the patient, he put the curtain. Okay, that is what this is. IF is equal to 1. Okay, so that the second patient is not allowed to enter to the doctor place. Okay, so once the treatment of the first patient is over, doctor opened the curtain and first patient has been sent out, like that. So here also, once the service is given to the first slow devices, along with the transferring the LR to the PC, it opens the interrupts. So that this is what you can call it as before taking the service to the first slow devices, it masks the interrupts. Okay, masking of the interrupt means, so the second device cannot generate interrupt to the processor while giving service to the first slow devices. So this is the difference between subroutine and interrupt.